Welcome to the Health Edge, translating the science of self-care. I'm Dr. Mark Pettis, and I'm with my friend, Dr. John Bagnulo. John, good morning, my friend.
Hey, good morning, Mark. It's great to see you. I know you got snow as well.
Great to see you. The snow season is here. Yeah, we got about 6 to 8 inches of fresh snow yesterday, and all the I'm reminded that so much of our local regional economy depends on snow, and so all of our ski areas and the cross country enthusiasts and are all celebrating. And with the Christmas holiday coming up, it's nice for there to be snow on the ground, and hopefully it'll still be there in a few weeks.
Yeah, hard to say.
Yeah, hard to say. So we have what I think is a terrific topic for discussion, John, and there's so much health information out there today that we all know of, and a lot of resonating themes that I find when I look at some of the sources that I like to go to for podcasts and real quality, credible information. And one of the themes that I don't see discussed a lot in those traditional and very popular circles is this topic of reduction and oxidation, and the extent to which redox pathways, systems in human biology, like all biologic systems, are very, very finely tuned. And that fine tuning can make all the difference with respect to not having too much oxidative stress, not having too much of reduction in what might be the form of megavitamins and antioxidants, which have become such a meme in the supplement world and marketing, and so I think, like all that we talk about, this is a very nuanced topic, and we'll go through a little bit of that research. But I'm really glad you brought this to my attention, John, because I haven't thought about it in a while, and I think these pathways are things that we can influence very significantly. And our objective today would just be to give the average Health Edge listener a kind of a 101 overview of what we're talking about with redox. What are our internal pathways that can help with that balance, and what we can do to allow those systems to work for us.
Yeah, no, it's. I know most of our listeners would identify with the notion that we have such a monolithic society, right? In so many ways, we get a direction, we get an angle, and we just go with it until till the extremes. And I think when you get into this discussion around oxidative stress, kind of neutralizing it, right? Because we know that oxidative stress is associated with aging and some deleterious effects on cellular health and our mitochondria and all these things, that we want to like throw a wet blanket on that little fire that we actually need to have burning at a low rate. And I think, exercise gives us so many benefits, and I think people appreciate those benefits, but I don't know as though the average person understands where those benefits start with exercise. And it's the stress, it's the dose of the stress that you create, it's the dose of the damage that you create to the myofibrils of the muscle. It's all those like low level damages, and oxidative stress, having higher levels of reactive oxygen species as a result of exercise brings about the very favorable changes that we want. And I don't think people understand that you're actually trying to elicit a physiological response by causing some low level inflammation, some low level oxidative stress, some low level tissue damage, from which you're going to come back bigger, stronger, more adapted to that type of exercise. And the magnitude of the response you get in exercise to a large extent is a result of this eustress, this favorable stress, right, that we're creating. So For me, it's fascinating, Mark, because, and you just said it really well. We're bombarded with, whether it's marketing or whether it's published papers, and sometimes that's a blurry, and I don't know if everybody appreciates how blurry it has gotten. But when you look at the published papers, let's say on a particular antioxidant, we could use resveratrol as an example. Someone is funding that typically, and it's, to a large extent, it's the manufacturers of a resveratrol supplement. And I'm not picking on resveratrol because it's a fascinating molecule. And don't get me wrong. I mean, I think there's certainly benefits to ingesting resveratrol. I think the dose might be really the missing component to that conversation. But we could say this about any antioxidant that is manufactured and then sold. It's a huge industry, right? So when you look at all the published papers on different types of antioxidants, if you look closely, they'll often identify the funding, and you'll see that it's a manufacturer, either a supplement manufacturer, a particular brand name at times. And there's nobody at this point in time. There's nobody funding, for the most part, a study on, looking at the consumption of, let's just say Concord grapes, right? It's going to be on resveratrol. And so that's where I think the whole playing field has really become tilted, so that we're bombarded with marketing on antioxidants, on particular supplements, and often papers are cited as evidence that, yes, this antioxidant will have this effect, but they might not share with us all the other papers that either showed no effect or very surprisingly, effects which would make you question whether or not you want to even take the supplement in the first place. So, yeah, it's fun. It's a fun topic because it weaves together so many facets of lifestyle, exercise, choosing the right foods on a regular basis. But to your point, Mark, understanding this oxidative, reductive process that's always ongoing, and how you got to try to maintain balance and not let it get too far one way or the other. But it's all about electrons. This whole this whole conversation is all about electrons, and I think that will benefit our listeners too, understanding that that's like 90% of energy production, health, health of our mitochondria. You can go in just so many different ways when you start saying, look, it's all about electrons. That's what this conversation really comes down to.
As we will share a few slides illustrating that, John, that's great, and it really does kind of bring us back to the principle that humans are electrical organisms, much as everything in our universe is. Nikola Tesla, just sort of inherently over 100 years ago, knew that to understand electricity, the flow of electrons, was to really unleash a much clearer understanding of how our universe works, and certainly how human biology works. And though that may seem like a bit of a leap, that's really what we're talking about here. And reviewing this topic also made me think of, I believe it was the great psychiatrist Carl Jung that once said, "That which doesn't make you stronger, that which doesn't kill you will make you stronger." And I think what we'll just illustrate as we go over these slides is that this human biology and the minute, tiny, low levels of molecular signaling it becomes essential in managing the yin and yang of our biology, oxidative stress and reduction, the sort of the response to that stress, and that because something might work in the lab or be suggested to correlate epidemiologically, more of that something, as there are many historical examples of, can be really detrimental and quite harmful. And we've certainly, as we'll touch on, we've seen that with good randomized control studies that, for example, have looked at high doses of vitamin A,
Yeah.
only to stop the study, suggesting that there might be actually a greater prevalence of lung cancer in people
Yeah.
at risk who take high doses of vitamin A. We've seen that vitamin E in very high doses has had little benefit, if any, at all, and in some examples might have worsened outcomes in cardiovascular disease, where it was widely studied some time ago. So these are outcomes that surprise the research community, because if something works mechanistically, you can demonstrate it. Maybe at a certain dose, it just does not often extrapolate well to human biology, particularly, and health, when you get into those more sort of pharmaceutical
Yeah.
um, doses of what might appear to work really well at a minute dose. And so it is a great biologic principle to keep in mind. More is not necessarily better. And we've
Yeah, I think
evolved.
that, yeah, Mark, what you just said, I mean, the pharmacological, pharmaceutical type dose is, again, that's just so unnatural. I mean, that's a word that I know people often take issue with, the word unnatural, but when in the context of a biological system, like what we're talking about here, whether it's redox, reactions at the mitochondria, wherever it is, when you're talking about that type of dose or exposure to an antioxidant, something that's going to donate massive amounts of electrons and completely put out the small flame that you need to kindle positive effects, it's so different than eating a food that would contain modest amounts of whatever, say, antioxidant is we're talking about. And the first time I ever encountered this, I was 25, 26 years old. I was doing some graduate work, and I was studying blueberries and the effects of blueberries on human health, and in particular women's health. And I was talking with the late James Joseph at the Tufts University Center for Aging, where Dr. Joseph did so much research on blueberries, spinach, walnuts, you name it, all of the foods that in the 80s and 90s researchers were identifying antioxidants that were really potent, right? They could really quench free radicals. They had the unique ability, because of their ring structures, to give up electrons easily. And he was finding in animal studies that all of these foods at, like 3 to 5% of an animal's diet was extending life. It was, the food we're talking about, typically freeze dried powders or fresh concentrates, they were changing things at the cellular level in a favorable way that would offset the aging process in, the lab in the animal. But this was the interesting part. When they took the antioxidant out of the blueberry and they gave the animals just straight anthocyanins at doses that were similar to what they would have acquired from food, from the 3 to 5% of their diet, or at higher levels, that the animals, that they didn't see any benefits in those animals, that they actually died at a younger age than the animals that got the control, that didn't get any antioxidants. So, I think from early on, I started to question, how much can supplements, or how much can these isolated molecules, to your point, administered in more of a pharmaceutical fashion at pharmacological doses, unnatural to what our genetics would have ever encountered. How much can we really? It's a gamble. I honestly, I don't think we can predict, but I think we can question not only the efficacy, and if they're going to be able to change things in a favorable way for us. I think we can question their safety from what you just shared with us. A few of those studies, and we have some others that we can show our listeners that are more specific to exercise and the benefits that you would hope to get from exercise that you don't get when you take a mega dose of a particular antioxidant. So it's just it's an amazing, again, it's an amazing topic because of how much it weaves into the discussion.
Great. I'm going to pull up some slides, and I apologize for those that are just listening to our podcast. But if you are interested, the slide deck will be available on our website, thehealthedgepodcast.com. We do have a YouTube channel with the video content for those that want to maybe see the graphics that we're sharing. And I'll do my best to describe these, but I'll pull these up, John. And the intent here is to just offer kind of a 101 definition of redox, what we're talking about, and then we'll look at a few of the studies that we're referencing in terms of these principles. But just to start with redox, right? We have reduction and oxidation. So this is sort of the yin and yang of how we donate electrons in the example of reduction, and how we lose an electron when we confront an oxidative challenge or stressor. So this homeostasis, this back and forth, is important in human health as a very dynamic equilibrium, right? Essential for all biologic processes. And just a few here that we often talk about on the Health Edge. Energy production, you reference mitochondria. This is a huge organelle around energy signaling and redox sensing. This is where, right, all of the electrons from the food that we consume are ultimately converted to energy. So it's a very active redox system. Cell signaling, how our cells communicate, our immune response. We might call that inflammation if it's not well regulated. And so maintaining this balance between oxidants, and we'll look at this in a little more detail, and antioxidants is critical. Imbalances in either direction can lead to cell damage, disease, and aging. And that's so important, right, John? You rarely hear anyone talk about the potential risks of pharmacologic dosed antioxidants, and that's really what we're talking about here.
Yeah, you rarely hear somebody say, well, you need a little more oxidative stress.
Yeah. Yeah, exactly. And this is, again, a simple schematic. When molecule A loses an electron, that's oxidation. And when another molecule picks up that electron, it is reduced. It is a reduction. And so this is really a flow of electrons. This is electricity, which is flow of electrons. And certainly there are areas in the body like the mitochondria where this is super active and super important. And just to kind of reiterate what we've been talking about, John, energy production in the mitochondria is obviously fundamental to human health. And as we've talked about often, virtually every chronic complex disease, from degenerative neurologic diseases to obesity and diabetes, insulin resistance, all demonstrate alterations in mitochondrial redox. Yeah. And so this is obviously an important area of human biology. Cell signaling and regulation, as I know you will elaborate on in terms of exercise, John, we know that in the example of exercise, when you're creating purposefully these reactive oxygen species, that dose will lead to a response. These free radicals are messengers, and our body senses these messengers and will then turn on the body's response, which attempts to keep that oxidative stress in check. And we talk a lot about these responses, particularly how lifestyle can adversely or positively affect systems like NRF2. These are transcription factors that will activate your book of life. It turns on many chapters in our book of life that can help with detoxification, preventing that inflammation from going over the top, to protecting our DNA, and so this is a response to those oxidative and reactive oxygen species signals, and so this is why you know. A purposeful creation of stress in this example is one that produces many positive effects because you activate these systems. And what always comes up for me, John, when I think about these systems is that we have built into our design pretty much the antidote for anything that modern life can throw at us. These systems are highly evolved in all mammalian and many non-mammalian life forms, and they are beautifully responsive when the stimuli are adequately triggered. And so part of the challenge for us is we have the software, but modern life and how our lifestyles translate often don't allow that software to activate. So, we have these state-of-the-art, right, operating systems. We don't need to upgrade our software, every 6 months as you might with your laptop. These systems are so finely tuned, but they require having adequate signaling to enable that. So,
and Mark, to add to that, I mean, the way you identified, some of the cell signaling here, how it controls the transcription and production of proteins, a lot of those proteins and enzymes have incredible antioxidant, much more so than anything we'd ever eat, right? So again, it's one of those things where we are so focused on the exogenous source of antioxidants that we don't really appreciate what we can produce endogenously if we allow that stimuli to persist at a low level. And it's not just at that level with the electron component to this and neutralizing oxidative stress with the enzymes that we can produce. It's also things as simple as lactic acid. I mean, lactic acid, we constantly expose our tissues to it. We start producing lactic acid dehydrogenase enzymes and versions of those enzymes that are really, really effective and work very quickly on converting lactic acid back to energy, to something we can use. But, the analogy I always use that's been demonstrated is people that take baking soda to neutralize lactic acid. Well, they don't get that adaptation. They might neutralize the lactic acid in that short window, and it can allow them to say, sprint an extra 100 meters or an extra 150 meters. So at the time of competition, it's understood and you can see the value in that. But in terms of training and helping the body adapt, the baking soda is actually counterproductive because it's preventing the body from experiencing the effects and the stimuli that lactic acid will produce, not just for skeletal muscle, but for heart muscle. So, that's just another example of a favorable stressor that we're creating. And it's the amount of that stressor that washes over tissues ultimately controls, whether it's going to be harmful or it's going to be beneficial. And it can be very beneficial, just like these reactive oxygen species can. So I love the way you always go back to the blueprint that we have, right? We've got this amazing blueprint physiologically to adjust, to adapt, and to become stronger versions of ourselves with these levels of eustress, these favorable stressors. So, it's just always keeping that in mind and not trying to override the amazing blueprint that we have.
Yeah, that's such a great example, John. I really like that. And another one that comes up for me is, when you look at fasting, intermittent fasting, time-restricted eating, we know that the stress from, let's say, food or energy deprivation leads to these adaptive
Yeah.
responses,
Yeah.
producing ketones, and how historically and even today, I think we continue to look at ketones in the example of fasting as dangerous. This is, and I'm not suggesting that fasting should be done without a thoughtful plan and maybe monitoring for some by a professional, but for the most part, you're activating systems that are alive and well in us and have been
Sure.
for hundreds of thousands of years. And so here you see ketones as a response as a response to the stress of a fasted state that unleashes this whole
Yeah.
host of benefits. And when one can begin to leverage low level stress as a way of activating the software that's alive and well in them, but maybe dormant, that's where the magic begins to occur. And this next slide, John, and the articles from which these slides have been pulled, I'll also have on our website, the open source articles that are available. But this, again, you mentioned, John, that our antioxidants can come from our endogenous internal systems, and the real geeks that listen to us hear about these powerful antioxidant systems like superoxide dismutase and catalase and glutathione, really important endogenous systems. And we know that oxidants, those pro-oxidants, those things that cause oxidative stress, are often just natural metabolic byproducts, which then stimulate these endogenous systems. And one of the great challenges in modern life, we often talk about the sort of gene environment mismatch, the extent that modern life now confronts us with oxidative stresses that no human perhaps before us has experienced, from the processed, ultra processed standard American diet to the sheer volume of pollutants and smoke and ozone and sedentary states, and these are incomplete lists,
Yeah.
Non-native light sources, things that we talk about all the time. So part of the challenge in modern life is the oxidative stressors are greater than what historically we have been adapted to adequately manage and regulate. And this is where our endogenous systems, even when they're working overtime for us, can't always keep pace.
Yeah.
And it's that mismatch that ultimately may lead to what we would call a disease like type 2 diabetes or Parkinson's or Alzheimer's or cardiovascular disease. And so this has relevance for all aspects of lifespan, disease risk, certainly quality of
Yeah.
life, or health span.
And so many of those endogenous antioxidants are nutrient dependent. So you may have the stimuli, you may have the stress, the reactive oxygen species that you're generating from the mitochondria when you run, when you train. But even with the stimuli, either you don't have the sulfur containing amino acids like cysteine or methionine to help generate some of these, or you don't have the zinc, let's say, to produce the superoxide dismutase, the selenium to produce the glutathione peroxidase. So that's where micronutrient deficiencies can also prevent us from having that endogenous antioxidant production or response that would be ideal, as you said, to keep up with kind of the modern load here and some of that allopathic reactive oxygen species load.
Yeah, that's a really great point, John. These systems require adequate substrate in
Yeah.
order to function in an effective way, and maybe more so now than ever, just given the burden of oxidative stress that we confront. And this is just again, these graphics. I apologize for those that can't see these, but this is just an example that we touched on of how reactive oxygen species, regardless of the sources for them, are messengers. And in this graphic, the messengers activate these transcription factors that we talked about, like NRF2. They might alter the expression of NF kappa B, right? A kind of a pro-inflammatory transcription factor, which you want turned on in response to an injury or a pathogen like uh, resistant Staph aureus. This is where
Yeah.
NF kappa B becomes a lifesaver. But when 24/7, day after day, week after week, these systems are skewed and poorly regulated, once we get into sort of chronic inflammatory states, we know that that's a kind of a passport to aging. So it's remarkable, right? How these small molecules that, get above top secret access to our cell nucleus,
Yeah.
turns on these transcription proteins, which can sense that higher reactive oxygen redox state, and then they produce the proteins, right? That
Yeah.
you would ideally want to reconcile that challenge. And here with exercise, John, and I'm gonna let you run with this, but and I'll make sure this paper gets uploaded. But all of the benefits of exercise, right, can be traced to the reactive oxygen response to that level of stress in ways that these pharmacologic doses of supplements are not going to be able to reproduce.
Yeah. Yeah. I mean, the mitochondria, again, they're front and center in this conversation. But if we look at the fundamental unit of a muscle or a sarcomere, we could start to get into some other areas as well in terms of microfiber changes or damage with resistance training. But at the end of the day, you're challenging a muscle to either produce more energy, again, albeit it's dependent upon oxygen and blood flow. So that's where the cardiopulmonary component comes into, let's say, aerobic responses or training. But at the end of the day, you're asking a muscle to extract more oxygen, from the capillaries that are around that. But the mitochondria are what's going to ultimately generate that energy. And mitochondria, like that's where the flame burns the hottest when it comes to reactive oxygen species and generating them. So when we're producing massive amounts of free radicals, because we're asking the mitochondria to produce so much energy, and there's just so much electron transport or exchange taking place there, the mitochondria adapts, and you'll see that mitochondria that are trained, let's say in an athlete or in a person that has embarked on a training program, their mitochondria are more resistant to the oxidative stress associated with that energy production. Now that takes place over time, but every bout of training results in those mitochondria becoming a little more resistant to oxidative stress. Now, how does that equate to better health? Well, we might exercise for an hour a day. We might exercise for 3 or 4 hours a day. It really depends on a person's lifestyle, everything that goes into that. But the other, let's say 23 to 20 hours of the day, you are in a positive redox state. So you have less oxidative stress, right? You have things tipped in your favor. You survive the bout of training, you adapt, and then you reap the benefits of that for the next cycle. And that's, I think a big part of this story is that we're causing low level stress with exercise, but the stress has so many advantages because downstream from that and for a bigger window of time, we're going to be in a better place in terms of our ability to resist some of that damage. So not to oversimplify it, but that's really a big part of this. And if we blunt that stress, right? If we prevent those free radicals from spending the minute amount of time around that mitochondrial membrane. If we blunt it too fast, we never get that response. And that's why we see in some of the studies, and we can talk about these that have been done with, and again, resveratrol is the one that I know off the top of my head. I think vitamin C, and you talked about vitamin E as well. Specific to exercise, that those athletes that take the mega doses, or we could call them more pharmacological dose, never do I want our listeners to think I'm suggesting we shouldn't eat vegetables and fruits or use curry in our cooking. Or, I mean, we get like very significant amounts of antioxidants from those types of foods, as well as from the coffee that we drink. We're getting antioxidants, hopefully, if our diet is constructed appropriately. We get antioxidants on a consistent basis throughout the day that help offset some of this tide of reactive oxygen species. So we're trying to take care of some of that fire, but we don't want to put it out completely. So I want to make sure I'm really clear when I say it that way. And with exercise, athletes who take a mega dose of antioxidants, they blunt the favorable response. So yeah, it's not just about like longevity, and it's really also, if we could look at it, the very short-term effects of how you may prevent a favorable adaptation to a particular type of exercise because of just not enough oxidative stress at a low level calling for favorable changes.
Yeah, that's great, John. And a common example to really share that teaching point around. Just a few more quick slides, and then we'll wrap this up, John. And really to kind of emphasize a point that you were just making. When you look at those, there are many dietary antioxidants that we hear about all the time, and when you obtain those in the packages that nature has produced us with, which, by the way, often have a multitude of these ingredients. So, when you're getting a nutrient dense vegetable, you're getting often multiple antioxidants, as opposed to sort of pulling one out of that.
Yeah, that's a great point.
Of that plant, and then super concentrating it and then taking it in an encapsulated form. But I like this because when you look at typical sources of these well described antioxidants in nature, they tend to occur in much lower doses. This is milligrams per 100 gram of food consumed, compared to what you see in these more pharmacologic doses of sort of antioxidant extracts, if you will, which continue to probably be one of the more popular over-the-counter supplements that are purchased by people. And then lastly, and this is kind of a summary slide from a very recent paper, pulling some of this together, how this balance is so intricately integrated with every aspect of human biology, and many of these now known to be hallmarks of aging and quality of life. And we've talked about some of these, from mitochondrial function and how cells regulate themselves, including cell death, what we call apoptosis. And there's a lot of interesting research now looking at senescent cells that are aging, but they're not taking themselves out of circulation in a timely fashion. And so the process of programmed cell death, which is important for human health, as these cells become more dysfunctional, becomes disrupted. Every level of, we've talked many podcasts about insulin resistance being one of the true drivers of all chronic complex diseases, inflammation. These are really the accelerants of aging. poor quality of life, intestinal barrier function, right? Leaky gut.
Yeah.
It
Yeah.
we don't I don't think typically, at least in the clinical world, we think of these as being so tightly connected to these redox systems. And then from, aging, as we've talked about, to degenerative neurologic diseases, cardiovascular diseases, and then, DNA. We've talked a lot in prior podcasts about epigenetics, the ability for DNA to repair itself in response to oxidative stress, and the very active ways in which a holistic, healthy lifestyle can optimize those systems so that we become less vulnerable to DNA damage that might ultimately translate into a disease state, or the epigenetics, the expression of our book of life, which, as we've talked about, has many possible expressions. Our book of life is hardly a fixed trajectory over which
Right.
we blame our genes and say our prayers, right? Not a very effective strategy for embracing life.
Yeah.
And then lastly, we talk a lot about protein structure and how, once the structure of a protein changes, everything about the function of that
Yeah.
system will become impaired. And so these systems are so important in maintaining this homeostasis, this regulation. And if you were going to summarize this, John, in terms of, and we've touched on some of these things over this discussion, but from a lifestyle
Yeah.
perspective, and again, this just sounds like stuff we talk about all the time because it's the same
It is.
playbook. How might this science guide in a practical way how you would help someone, John, struggling with their health?
Yeah. I think it's good to look at the sources of oxidative stress in one's life. And you can look at this in a lot of different ways, but don't look at the oxidative stress that's generated by exercise as being the primary cause of an imbalance that you may have, right? I mean, I like to look at things like the amount of polyunsaturated fat that maybe we're ingesting inadvertently through a lot of what might be, foods with some good virtues, some good characteristics. We could talk about, different types of nuts and seeds. And then we can get to areas that, I think people should be really vigilant and cautious around would be like seed oils, right? If you're consuming like sunflower, safflower oil, corn oil, canola oil, and all these polyunsaturated rich oils, then you're making your mitochondria essentially out of a very flammable type of fatty acid that's going to generate massive quantities of reactive oxygen species when it's washed with what you generate in the mitochondria and energy production, right? So, I look at that, for instance, as being a lifestyle component, the types of fats we choose, and ultimately that we build our organelles, our mitochondria, and our phospholipid bilayer out of. I look at that as being a major determinant in the amount of oxidative stress that we're going to experience, and it's going to really have an effect on the aging process, whether it's neurological, whether it's cardiovascular. I mean, there's some really interesting papers out there on what happens when we become too polyunsaturated fat comprised, right, from all those fats. Like there's an area where you can take more control over reactive oxygen species and not let that candle, which you need, don't let that candle become a brush fire or a wildfire and it's burning out of control. But let the candle burn. Don't put the candle out because you're going to need that. You need that little bit of it's going to really catalyze. It's going to drive very favorable effects in the body. So keep the candle burning. Don't put that out and prevent the brush fire with some lifestyle characteristics that are going to have a far more favorable effect widespread, which would be the types of fats you eat, stress reduction, right? Whether that's through meditation, Practicing gratitude, that's going to keep your oxidative stress levels lower. Find that balance of exercise where, you're in the right intensity. So you're not always zone 4 asking too much of, like, let's say a cardiopulmonary response. You're getting too much cardiac stretch. You're starting to get calcium leaking out of the cardiac tissue. That's when it's excessive. All the studies on exercise, and you and I have talked about this, Mark, show that, people who walk or run somewhere between 30 and 35 miles a week, they seem to have a better overall trajectory of health than people who run 50 or 70 miles a week. Is it too much stress? I think that's where we can go there pretty quickly when you start to look at some of the very interesting studies, albeit a handful, that have been done by guys like James O'Keefe, who's I think a awesome cardiologist, because he asks those questions about what's too much of a stressor on the heart, and what are the effects of too many polyunsaturated fats, specifically when they're incorporated into cardiac tissue. So we can go in those directions for very attainable lifestyle changes. Find balance with your exercise, eat less polyunsaturated fat, right? And get your antioxidants from things like, well-made coffee, and from having berries with your yogurt, or from eating more, spices like curry when you cook. That's where I think you create that beautiful mix, as opposed to, putting some of that stuff aside and taking pills with X, Y, or Z amounts of a particular antioxidant.
Yeah, that's great, and it really does come back to that blocking and tackling.
Yeah,
and
for sure.
The and to that amazing list, time restricted eating, 10-hour window, intermittent fasting, not unlike exercise, though perhaps not of the same magnitude of effect, right? We do know that as a stress state, fasting will turn on these reduction systems, regenerative and repair systems, and so that can be a periodic way to get that effect. I'm always intrigued by the sauna research,
Yeah.
how time in saunas, and for those that like the polarity, the cold plunge, the sauna experience, those extremes are stressors, right, on human biology. But when the dose is right, the benefits are unbelievable. You're
A
turning on
great
all these
example.
systems. So sauna,
That's an awesome example, that because of the heat shock proteins that you generate with that exposure, that's an awesome example.
and we know that it can mimic many of the same mechanisms, health mechanisms, as exercise, right? So I do think when we look at relatively simple cold exposure, some heat exposure, right, nutrient dense foods, movement, we know that light, and certainly full spectrum light and infrared light in particular, that comes from the sunshine, is a major source of electron flow in mitochondria, and a great source of energy production. So again, nothing new here in terms of what we might recommend, but tying it to these mechanisms, hopefully for those really interested in these topics, can appreciate why it is that these things are so important, and why what might seem to be great in a low dose and a high dose will not, it will often not have the intuitive outcome that one would predict. And that's the beauty of human biology. And I think that's why the N=1 that we talk about is so important, John. So much of the research, I think, will fall short in really helping individuals translate things into their own lives, because the designs are set up for sort of black and white kinds of outcomes. You don't see a lot of the nuance and subtlety that you might see when you make a change in your life, like cutting out processed vegetable oils, or sugar, or carbohydrate dense grain based flour, and then seeing how you respond to that will be the best indicator of where your redox balance is at. You don't have to measure your redox balance, to realize that something you're doing is either bringing you closer to where you would like to be, or maybe taking you further away from where you'd like to be. So our instincts are so sharp when we create enough stillness to allow them to reveal whether the path we're on is serving us well or maybe not serving us too well. And so this is there's that beautiful sort of intuitive sixth sense, right? That spiritual dimension to this, John, that's so important. Just right in this material, scientific reductionist world that we're in, which sometimes I think is taking us further away from those finely tuned, instinctive experiences and knowledge that we've acquired.
Yeah, well said. Really well said. I think a lot of times people are being told what to do instead of feeling what's right. And I think that with so much of the lifestyle discussion, that's what it comes down to.
Definitely. Well, good discussion, John. Rich, and I love this, and what a joy to be able to dive in. We're going to be looking at a paper that I think will be of real interest to folks, John, that raises the question of whether is coffee, if you have atrial fibrillation, which is one of the more common heart dysrhythmias, is drinking coffee bad for you? And that's certainly been, I think, the clinical meme. We'll take a look at some more recent research challenging that clinical meme. And I think for the coffee lover, this will just be another bit of good news. So I look forward to sharing that next week.
As do I. Love you, brother.
Love you too, John. You embrace the snow and keep those hormetic effects coming in your life. It benefits us all, and I'm grateful for that. And we'll see everyone next week.